All right, so some of the questions that I've had have been, different ways to write the answers, and we can talk about those in a few minutes. But let's take a look at number 12. Problem number 12. So they're both underneath the radical. So the first thing I'm going to do is ask myself, can I reduce 16 over 3? No, 16 is not divisible by 3, and there's no common factors that help me to reduce 16 over 3 or simplify 16 over 3. So now I'm going to say, okay, I am looking at this, and I need to think of this as the square root of 16 over the square root of 3. And some of you get what I call rationalize happy, where you just want to rationalize the denominator multiplied by square root of 3. And you can do that, but you're going to create a lot more work for yourself, because what is the square root of 16? This is just 4 over the square root of 3. Now rationalize. So now multiply top and bottom by square root of 3. And when I do, I get 4 square root of 3 over 3. Now, someone asked a very good question. They said, I have, the board does that. Okay, really? Okay, so ignore that line that's going through everything. They said they have 4/3 square root of 3. Is that the same thing? And it is. It kind of goes along with, do you guys remember when you had let's not even use 1/2. Let's use 4/3. If you had 4/3 x, that's the same as 4x over 3. Same thing is true with your radical. And the reason is you can put this over 1. When you multiply, you get 4 square root of 3 over 3. So it is the same answer. So I don't care if you put the 4/3 square root of 3 or 4 square root of 3 over 3. Same thing. You just can't have it in the denominator. All right, did I answer whoever needed number 12? Did I answer your question? Okay. Number 15 was another one that somebody had asked for. Okay, so this 3 is on the outside, and then I looked at 2 over 3 and said, can I reduce 2 over 3? I can't. So I'm just going to do square root of 2 over square root of 3. And now I'm going to rationalize. So now I'm going to go ahead, since I can't simplify it all, I'm going to rationalize. That 3 is still out front. 2 times 3 is 6, and then that gives me 3. Now I'm not sure who asked me this, if they were thinking they could simplify further somewhere, but you can't. Remember, you have to keep radicans with radicans and numbers with numbers. The radicans are the inside numbers, innies with innies, outies with outies. So this number, the square root of 6, can't go with anything. You cannot do anything here because the denominator of that 3 would be 1, so you don't have like denominator, so you're done. Did I answer 15? Whoever asked for 15. I can't remember who it was. Are we good? A lot of you asked for 19 and 20 both. Okay, 19 and 20 both. Again, lots of ways to do these. I look at number 19 and I see the square root of 20, and as time goes on, you're going to see the square root of 20 and say, that's not simplified. I can break up square root of 20. So let's come off to the side and break up square root of 20. What can you guys break 20 up into such that one of them is a perfect square? 4 and 5. And what's the square root of 4? 2 square root of 5. So do you guys see I have 2 minus 2 square root of 5 all over 3. I think maybe some of you thought you could do 2 minus 2. But you can't. It's just like if I had 2 minus 2x. Can you subtract 2 minus 2x? Why? You don't have like terms. Like terms, you have the same variable with the same exponent. Well, same thing is true with radicals. In order to add or subtract radicals, you have to have the same radical. You have to have radicals with the same thing underneath. So this does not have a square root of 5. So you cannot subtract those 2's. So I'm looking at this going, okay, I'm going to leave it like this. If by some chance you wanted to break it up and tell me 2 over 3 minus 2 square root of 5 over 3, that's the same thing. It didn't help me because nothing reduced. You always got to check to see if something reduced, but it didn't. So you're done. So I would accept either one of those answers. Did I help clear up 19? All right, same thing with 20. 20, I'm looking at the square root of 150, and I'm saying, okay, I know that's going to reduce. What number goes into 150? That's a perfect square. Okay, 25 times what? 6. What's the square root of 25? 5 square root of 6. So I have 4 minus 5 square root of 6, and this is all over 5. Once again, you cannot subtract your numerator because you don't have like radicals. So I'm going to break this up. 4 over 5 minus 5 squared is 6 over 5. You do have to do this one. You have to break it up. You have to break it up. And the reason you're allowed to do that, okay, if I had 4 over 5 minus 5 over 5, how would you guys subtract this fraction? What math would you guys do to subtract this? You do what? You do 4 minus 5, and then you put it over what? So do you see how I'm allowed to go backwards? So going backwards, I'm just doing 4 over 5 minus 5 over 5. And so now I'm looking at this. Can you reduce 4 over 5? No. What can you do with the 5s? Cancel, and you just get square root of 6. If you have a 1 in front of the square root of 6, it's no different than if you have an x and 1x. If you have a square root of 6 and 1 square root of 6, it's the same thing. Okay? How do we do? Did I answer all your questions? Does anybody need any more from the homework last night? Okay, pass the blue papers in. Get your graphing calculators out today. This weekend, that's your only homework assignment. Homework minus. I keep the caps, so I remember to put that back in here. Okay. Because yours is the one that's broke, Ava, right? Yeah. Okay. So, we are now going to work. We've talked a whole lot so far about factoring, we've talked about reducing and simplifying radicals. So now we're going to actually start chapter 3. And there are many different ways we can solve quadratic equations. When you guys were in Algebra 1, we solved by using square roots, solved by factoring, solved by completing the square, and solved by quadratic formula. Does some of that sound familiar? Might not remember how to do it, but hopefully at least kind of sounds familiar. This lesson addresses a quadratic formula. A quadratic equation can be written in the form ax squared plus bx plus c equals 0. Okay, that's quadratic. Ax has to have an x squared. Where a, b, and c are real numbers, and the only one that can't be 0 is a. Because if a is 0, then it's not x squared, then you have a linear. Okay? So b and c can be 0. You don't have to have an x term. You don't have to have a constant term, but you have to have an x squared term. Okay? The root of an equation is just the solution. So you're going to hear some words interchanged. The root, the 0, the solution. Those are all the same thing. You can solve it by graphing. That's what we're going to work on today. We're going to solve by graphing today. The x-intercepts are the roots or the solutions when you are graphing. So if you're graphing, you just look for the x-intercepts. Those are the solutions to this quadratic. We can use square roots. We're going to do that today. You're going to isolate the x squared, the m squared, the whatever squared, get everything else to the other side, and then just take the square root of each side. okay? And then the last one we're going to do is by factoring. We'll do that next week after our long weekend. So let's talk about this one. Solve by graphing. You may use your graphing calculator, so you don't have to draw any graphs here for this. So let's grab our graphing calculators. Let's go to y equals, and it looks like the last thing we did was a scatter plot. So I'm going to clear out that. I'm going to turn off my plot. Remember, you have to have your plot on when you are graphing statistics to lists. Want your scatter plot. That plot has to be off when you are graphing just functions. And I'm going to type in x squared. So I'm going to use the x. Remember, x is catty corner from the second function squared minus x minus 6. And we want to know, when does that equal 0? Well, 0 is the y, when y is 0, and that would be at the x-axis. So that's why you're looking at the x-intercept. X is right here. Oops. Catty corner from the second function. Now, if I just press graph, who knows what my last window was? The last time we did that statistics problem. So how do I graph just functions? Zoom what? Which one? 6, which is standard. That standard window will go from -10 to +10 by a scale of 1 on the x-axis and -10 to +10 by a scale of 1 on y. Did everybody get this graph okay? Did you get it, Paige, or are you still working?
I
Didn't get it. Okay, yeah.
Oh, wait.
Okay.
Is that?
Yeah, that's not supposed to be there. Oh, you could have just pressed through. That's all right. X squared
There's an X right here.
minus x minus 6. What is that? Okay. Second quick. Second quick. There we go. Okay. Is everybody else good now? Alrighty. So now the zeros appear where my x-intercepts are. So here and here. Now, we don't know exactly what these are. We could guess. They're not going to always be perfect numbers. So we are now going to use another feature of our second calc. We've talked about value. Value, when you do that, that says, what do you want me to let x be? You tell the calculator what you want x to be. It gives you y. That's not what we need here, okay? We can use the minimum or the maximum. That's if you want to find the vertex, the minimum of this or the maximum, okay? But what's number 2 say? 0. So I'm going to go down to number 2, and I'm going to find the 0 of the function. Now, I want to explain something before you guys start pushing buttons. It's asking again for the left bound and the right bound. Okay, don't think up and down. It doesn't say what's up and what's down. You need to be to the left of one of the zeros. It doesn't matter which one. I'm going to find the one on the left first. So I need to be, my cursor needs to be to the left of that 0. So somewhere up here. Now yours draws a line. And then I need to be to the right, somewhere down there. And then it says, do you want me to guess? And I say yes. It's going to find the 0 between those two lines. That is, where does y equal 0 between those two lines? So now I'm just going to say, okay. So let me do this one. So I'm going to go left bound, enter, right bound, enter, hit enter again. What is the first solution? Where does y equal 0 for the first one? -2. There's one solution. X equals -2. Now, the next one, when I find the other one, left bound here, right bound here, find it between. All right, so again, I'm going to go second calc, number 2, which is 0. I need to have the left bound, so I just need to be somewhere to the left of that 0. Hit enter. Somewhere to the right of that 0. hit enter. Do I want my calculator to guess where it is between those? Yes, hit enter. Where is my second solution? 3. Now, let me show you what you do wrong. There's 2 things you do wrong when you do this, okay? The first thing that you do wrong is you do left bound, right bound. Now, guys, how many zeros are between those 2? 2. When you hit guess, it will go to whichever one your cursor is closer to. It'll go to whichever one your cursor is closer to, which is going to be the one on the right. All right, because that was right bound. So it'll not take you over here unless you move your cursor over there when you hit guess. So make sure when you are going left bound and right bound that you are including the 0 you want between your bounds. Okay? All right, let's try another one. What do you guys think so far? Ooh, what's wrong with this equation? It's not equal to what? Yeah, we got to get it equal to 0. So how am I going to get this one equal to 0? We got to set it up right. AJ?
Subtract 4x.
And when you subtract 4x, and let's get it in the right form, the right order, what do you have left?
Negative 2x squared minus 4x minus 2
Equals
0.
Okay, so we're going to go back to our calculator. Go back to y equals. I'm going to clear this out. I'm going to do negative 2x squared minus 4x minus 2. And now I don't have to go zoom 6 again. Like once you set that graph to standard, it'll stay at standard unless you mess it up. Uh-oh. How many places does this one appear to hit the x-axis? Yeah, 1. Do you guys see that? Yeah, it only hits 1 time. Okay, now, if you want to make sure, because maybe, just maybe, the graph is doing that, but we can't see because we're not zoomed in enough. Okay, you can do another zoom. This zoom is called zoom box. Okay, so let's kind of zoom in just a little bit and see if by chance that's happening on this graph. So once again, I'm going to go to zoom box. And when I do, I'm going to start moving this cursor around. So you have a floating cursor. And I'm going to put that cursor in one corner of where I want my new window to be. So once I get it there, I'm going to hit enter. And now I'm going to come down and over. And what I'm doing is I am creating a box, and once I hit enter and get that box the way I want it, that box is now going to be my new window. Does that make sense? So I just did a zoom box. There's my box. So now when I hit enter, I can see how many times did it hit? It just hit 1. So how many zeros? Remember, you can have 1 0, 1 solution, 2 solutions, and you might not have what? Any. It might open up and be above the x-axis, or open down and be below. So there might not be any. All right, so let's go ahead. We can use this second calc, what? 0. You can still do left bound as long as you're up over this hump. So left bound. Oh, mine kept going. Enter. Right bound. Okay, enter. And when you guys hit enter, what did you get as the solution? Ah, I'm glad this happened. Okay, we zoomed in so far. I got negative 1.00001. Did anybody get negative 0.999999? What'd you guys get?
I did.
You got both? You did it 2 different times? You got both? You got exactly negative 1? Okay, it just depends on how far you zoomed in, the pixels of your calculator. I'm going to say let's round to 2 decimal places. Okay, if we round to 2 decimal places, what's x? Yeah, so x is negative 1. Questions? Okay, leave your calculators out. We'll come back to that in a minute. That's solving by graphing. You will be allowed to use your calculators for that. Is that pretty cool?
How can you get rid of the box?
Oh, okay, so now if I want to go back, just go zoom 6. And it takes you back to your regular graph. Okay? Zoom 6. Zoom 6 always takes you back to that standard negative 10, 10 to 1. Okay, next one. Solve by using square roots. So what we want to do is isolate that x squared. Get that x squared all by itself. So Jarrett, what are you going to do to get the x squared all by itself?
Don't you multiply 49 by 4?
Not yet. We got to get the x squared by itself. What would you do if I gave you this equation? And I told you to solve for x. What would
Add 31.
Yeah, so what are you going to do here? Add 31. When you add 31, what do you have left?
4x squared equals 80.
Okay, now we still want to get the x squared by itself, so what are you going to do now?
Divide by 4.
Now you see it. Divide by 4. So now you get x squared equals what?
40. Or 20.
Alright. Are we good so far? Okay, well, now we've got to undo x squared. How do you guys undo x squared? Take the, now be careful. If I had x squared equals 25, what could x be? Or, do you guys agree? What's 5 times 5? What's negative 5 times negative 5? So I have to put a what?
Plus equal.
Okay, so when you take the square root of each side, do not forget a plus or minus. You are not going to put the square root of 20 in your calculator because now we know how to simplify square root of 20. What are you guys going to break square root of 20 up into? 4 and what's the square root of 4? So this is 2 square root of, no. Questions? All right, try this one. Let's look at this one once. Addie, what are you going to do on this one? Subtract 9. And when you do, what do you have left?
3x squared equals 9.
Equals what? Equals,
Negative.
there you go. Now what?
And divide by 3.
And what do you get for x squared?
Negative 3.
Negative 3. All right. Now what would we do? Take the what? But Addie, do we have a problem right now? We won't in a few weeks. Taking the square root of a negative. What multiplies? Think of this problem. X squared equals negative 25. What number multiplies by itself to give you negative 25? But negative 5 times negative 5 is positive 25. Is there anything?
No.
So what do we say? Now I'm going to make an important word. No real solution. Because we are going to learn this year very soon about non-real solutions. Because we're not having enough fun with real numbers. We're going to add non-real numbers to your life. Okay. All right. This one is getting you ready to complete the square. Getting you ready to complete the square. You are not allowed to distribute the 2/5. That's a big no-no. I heard it. Oh, okay. Because you'd have to do the square first, and you'd have to FOIL, and yeah, no. Okay, watch. How do I get the 2/5 to go away?
Divide.
Okay, you can divide by 2/5, or you can multiply by 5/2. Multiply by 5/2. When you do, you get x plus 3 quantity squared equals what? 5 times 5/2. Well, this is like over 1, so what would that be? 25 over 2. If you are calculator dependent, you do 5 times, and then in parentheses, 5/2. And then when it gives you 12.5, you know you can't have decimals in this chapter, so you're going to go math to a fraction. Okay? Did I hear a what? Okay. 5 times 5 halves is 5 divided by 2. Hit enter. And then under math, the first thing you see is answer to a fraction, and it takes you to 25 halves. All right, now what do I do to undo the squared? Take the what? Square root. Okay, what do we put out front? I'm going to put x plus 3. What do we put out front of this? You have to remember a what?
Plus or minus.
Plus or minus. Now I heard an oh wait. All right, I'm going to come off to the side and call this square root of 25 over square root of 2. You see why we did what we did last night? What's the square root of 25?
5.
So this is 5 over. Now what do we do?
Oh no.
Multiply by radical 2.
And when you do, what do you guys get? 5 radical 2 over 2. Still got to get x by itself. What do we do now?
Minus 3.
Minus 3. And when I do, I get x equals. Now, anytime you have a number plus or minus another number, you always put this number first. Negative 3 plus or minus 5 square root of 2 over 2. And we're done. And you can kind of see why we did what we did yesterday. Now, leave these out. Leave these out. You're going to turn them over. Okay, you don't have homework tonight, so here's what we're going to do right now. Okay, this would have been your homework. Do the first 3 graphically. Go. Yeah, on your calculator. I'll be around to help if anybody needs help.
Really good.
Yes.
No.
Grab the blue papers because I forgot to grab them. Thank you. Did I get all the blue papers?
Oh, I got like the .99.
Okay, so yeah, last time you didn't.
Yeah.
Oh,
Just round it.
so just round up. So what's 0.99? 1.
I got negative. How? How do I get just one?
Just one.
Okay, let me grab my answer key.
How do I get negative?
It's not negative.
Wait, you get negative 1 too?
I just plugged it in.
Yep.
Wait,
Okay, so go back to 1.
How
Okay, go to Zoom 6.
do I get negative 1?
Plus 6. They did really bad.
You were still on the
Oh,
other
John,
problem.
no solution.
Yeah, you were zoomed in from your other problem. Yes.
So I got 0.
How do I get negative?
I got negative on this side.
Okay, let's see your problem.
When it doesn't hit 0.
Well, because that's not the problem. It says 3x squared equals 6x minus 3. So you have to either bring the 3x squared to the right.
No
I thought the same was on the left side.
No real solution.
Yes. Okay, what number are you guys on?
3.
Third one?
They did really bad.
Why is my calculator not?
Oh, dude, I gotta go Windows.
Hello?
Judge
What the
Google.
heck? I don't know.
Zoom 6 is Zoom 6.
Wait.
Oh.
No,
That's the way.
What's up?
I don't know what happened here.
Oh, wow. Okay, you put cubed instead of third. Oh, you put, okay, you have times, you have x to the second times negative 2x, which when you do that, it becomes x to the third power, and that's a cubic function. That's how I knew that right away. I'm like, you have x to the third. So, you needed to type that in better. Okay. All right, what number are we on? On number 6, you can either bring the 3x squared over to the right and have negative 3x squared plus 6x minus 3, or bring the 6x over and the 3 over and have positive 3x squared minus 6x plus 3. Either way, your x-intercepts will be the same. X-intercepts will be the same. What did you get for the x-intercepts on number 6, Karina?
I got 1.
X equals 1 is the correct answer. X equals 1. Caleb, what'd you get for number 2?
No real solution.
No real solutions. How'd you guys? It didn't intersect at all. It was above or below, depending on which way you brought it over. Yes, sir.
I subtracted x squared and 2.
Okay, and that's fine. So you had it still should have been no real solutions. You had negative x squared plus 2x minus 2.
Yeah.
And you had no real solutions.
Yeah.
Yeah, same thing. You all have the same answer.
Okay.
Yeah, you still have no real solutions. I just thought most people would have brought this over, but if you brought those over, that's fine. Okay, how about number 10? McKenna, what did you get for number 10?
I'm still working on it.
Okay.
For the first X, I need help with this first X.
Why?
It's coming up as like. So put it right on it.
Okay. So, how?
And then I go left down.
Don't push that until you're ready. Are you, which one are you trying to find?
Let me get set into it.
And then right of it.
Oh, no, wait a minute. Okay. Second back. Okay, your X intersection is down here. There is no 0 between there and there. You never cross the X axis. Okay, here. And now below, yeah, there. And now, is there an X-intercept? No. Enter. Is asking you, do you want me to guess?
Why wouldn't you just subtract the
Okay, again, you might have to change your window. Change the window.
Alright, well, I'm doing it this way.
Take your X max out to like 15. Did you guys take your X max out a little bit?
Yeah, I've been trying to do that and it's not working.
Okay, guys, on number 10. On number 10. Okay, let me do this with you. Did most of you write it this way?
Yes.
Okay, so 1/4 x squared minus 3x plus 5. Zoom 6, because I don't know if I changed it at all. Now, I did my first one. What did you guys get for this first 0 right here? Okay, we got x equals 2. Is everybody good with the first one? Now, what do we have to change in order to see this 0 here?
X max.
X max. So I'm going to go to my calculator. I'm going to go window, and I'm going to make my X max. Let's make it 15. Now, guys, if you tell it 15 and then go back to zoom 6, it's going to change it right back to 10. Right? Okay, every time you go zoom 6, it says, okay, negative 10, 10 divided by 1. So once you hit 15, just hit graph. Now it's stretched out. And now I can do second calc, 0, and now I'm going to do left bound. So again, left bound, anywhere to the left of that, right bound, anywhere to the right of that. Okay, it's like going forever. Okay, enter, enter. And did you guys get x equals 10?
Yep.
Okay, how you feeling
Good.
on the graphing ones?
Copy.
Okay, we'll start warm up with some square root ones on Tuesday. Have a fabulous weekend. Good luck, everybody that's competing, racing, or performing.
What happened now?
Are you good now, Karina?